Ever wondered how the universe is so perfectly synchronized, or why things behave the way they do at an atomic level? Welcome to the fascinating world of quantum physics. Quantum physics, also known as quantum mechanics, is a branch of physics that ventures into the enigmatic realm of atoms and subatomic particles. It's a world where the rules of classical physics cease to apply, and new, intriguing phenomena take center stage. But what does this field of study seek to comprehend? Simply put, quantum physics strives to understand and explain the fundamental nature and behavior of the universe at its most microscopic. This realm of science might sound like a product of modern ingenuity, but its roots trace back to the early 20th century. It all started with a man named Max Planck, a German physicist. When a classical approach failed to explain the radiation of energy from heated objects, Planck proposed a radical idea. He suggested that energy at its core was quantized, meaning it existed in discrete amounts, which he called quanta. This groundbreaking idea, though met with skepticism initially, opened the door to a new understanding of the universe. Following Planck, many brilliant minds, including Albert Einstein and Erwin Schrödinger, contributed to the development of quantum physics. Einstein's work on the photoelectric effect further supported the idea of quantization, while Schrödinger, with his wave equation, introduced the concept of wave-particle duality. But this is just the tip of the iceberg. Quantum physics is a vast field, filled with mind-boggling concepts like superposition, quantum entanglement, and uncertainty principle. It's a universe within our universe, a world that is paradoxically predictable and unpredictable at the same time. It's a realm where particles can exist in multiple states simultaneously, where they can be both here and there, both moving and stationary. So, buckle up as we dive deep into this quantum realm and decode the mysteries of the universe. Imagine if you could be in two places at once. Sounds impossible, right? Not for particles in the quantum world. Picture a bustling city street, cars zooming by, pedestrians rushing to their destinations, each entity distinct, confined to one place at a time. Now let's transpose this image to the quantum world. Here things don't play by the same rules. An electron, for instance, can exist in multiple places simultaneously. This is the mind-bending concept of wave-particle duality. To understand this, let's consider light. We know it as the bright stuff that helps us see, but it's also a particle and a wave. It's like a superhero with a dual identity. By day, it's mild-mannered Clark Kent, and by night, it's Superman. In the quantum world, light can be both at the same time. When light acts as a particle, it's like a single grain of sand. You can pinpoint it, measure it, and say, here it is. But when light behaves as a wave, it's more akin to the ripples in a pond after a stone is tossed in. It spreads out, it interferes with itself, it's everywhere and nowhere. Now, if you're wondering how this is possible, you're not alone. Even Einstein struggled with this idea, calling it spooky. But numerous experiments like the famous double-slit experiment have confirmed this strange behavior. When we're not looking, particles spread out like waves. But the moment we observe them, they snap back into being particles. This quantum quirk challenges our everyday logic. We're used to a world where things have a set location, where they can't be in two places at once. But in the quantum world, the rules are different. Particles can be in many places at the same time, they can take multiple paths, they can even interfere with themselves. In the quantum world, reality is stranger than fiction, and wave-particle duality is just the beginning. Scene script. Ever tried to measure something, only to find that the act of measuring changes the thing you're measuring? Welcome to Heisenberg's uncertainty principle. Let's take a journey into the quantum realm, where the rules of the game are unlike anything we're accustomed to. Here we encounter a quirky principle known as Heisenberg's uncertainty principle. This principle tells us something quite startling. It's impossible to know both the position and momentum of a particle at the same time. Imagine you're trying to take a snapshot of a buzzing bee with your camera. You might get a clear image of the bee at a specific point in space, but you won't be able to tell how fast it's moving or in which direction. On the other hand, if you try to capture the bee's speed and direction, the image becomes a blur. You can't pinpoint its exact location. This is essentially what Heisenberg's uncertainty principle is about. But instead of bees, we're dealing with particles like electrons. The more precisely we try to measure a particle's position, the less precisely we can know its momentum, and vice versa. This principle isn't due to any limitations of our measuring tools, it's a fundamental aspect of nature itself. This means that the quantum world is fundamentally fuzzy and uncertain. Now, you might be thinking, how does this relate to a quantum dice? Well, every time we make a measurement in the quantum world, it's like rolling a dice. We can predict probabilities, but we can't know the outcome for sure until we check. In the quantum realm, particles don't have definite properties before we measure them. They exist in a superposition of states, and it's only when we make a measurement that they choose a state. This is a far cry from the deterministic world we're used to, where the roll of a dice is determined by the initial conditions. In the quantum world, even if we know all the initial conditions, we still can't predict the outcome with certainty. So, in the quantum world, certainty is an illusion, and unpredictability the only constant. Imagine two particles, separated by vast distances, yet behaving as if they are inseparably linked. This is quantum entanglement. In our everyday lives, we're accustomed to the idea that actions have local effects. If we kick a ball, it moves. If we flip a switch, a light turns on. But in the world of quantum physics, things aren't so straightforward. Here, we encounter a phenomenon that Albert Einstein famously referred to as spooky action at a distance: quantum entanglement. Quantum entanglement is a curious quirk of quantum mechanics where two particles become inextricably linked or entangled. This means that the state of one particle is instantly connected to the state of the other, regardless of the distance between them. It could be inches, miles, or even light years. The effect is instantaneous. Now you might be wondering how this is possible. After all, doesn't this violate the speed of light restriction from Einstein's theory of relativity? Well, that's one of the great mysteries of quantum entanglement. It doesn't seem to transmit any physical thing or information faster than light. Instead, it's as if the two particles are one and the same, mirroring each other's states instantaneously. Imagine it like this. You have a pair of gloves, one left-handed and one right-handed. If you pack them into separate boxes and send them to opposite ends of the universe, the moment you open one box, you instantly know the contents of the other. If you find a left-handed glove, you know without a doubt that the other glove is right-handed. This is a crude analogy, but it gives a sense of how entangled particles behave. The moment one is measured, the other knows and assumes a corresponding state. This phenomenon has been proven in numerous experiments and forms the backbone of emerging technologies like quantum computing and quantum cryptography. It's a strange and counterintuitive aspect of our universe, but it's a fundamental part of the quantum world. Quantum entanglement shows us that at the quantum level, the universe is deeply interconnected in ways we're just beginning to understand. Quantum physics, it's a lot to take in, isn't it? But don't worry, it baffles the best of scientists too. It's a realm where conventional wisdom takes a back seat, and the impossible becomes plausible. It's like stepping into a parallel universe where the rules of the game are entirely different. In this enigmatic world, we've encountered the quantum quirk, where particles can exist in multiple states at once until observed. This is the principle known as superposition. It's a bit like your coffee being both hot and cold at the same time until you take a sip. We've also rolled the quantum dice, where randomness and probability reign supreme. It's as if the universe itself is playing a game of chance, with outcomes only determined when we decide to take a peek. Then there's the spooky action at a distance, or quantum entanglement, where the state of one particle can instantly affect another, no matter how far apart they are. It's like two friends separated by oceans yet feeling the same emotions at the same time. Yes, it's all quite bewildering, but it's also fascinating. It's the language the universe speaks, the underlying code that defines our reality. It's the science that allows us to build technologies like quantum computers, which could revolutionize our world in ways we can't even imagine yet. Quantum physics is not just about tiny particles and complex equations. It's a journey into the heart of the universe, a quest to understand the very fabric of reality. It's a testament to human curiosity, our insatiable desire to unravel the mysteries of existence. So don't be daunted by the complexity. Instead, revel in the beauty, the strangeness, the sheer wonder of it all, because it's in these odd corners of the universe that we find the most profound truths. So next time you look up at the stars, remember, you're not just looking at a sky full of light, you're peering into a quantum universe full of endless possibilities.